Hello class, today we'll be learning how to construct a confidence interval to determine if there is difference between matched pairs. To do that, we'll be looking at section 9.3 number 2. Data on the numbers of hospital admissions resulting from motor vehicle crashes are given below for Fridays on the 6th of a month and Fridays on the following 13th of the same month. Assume that the paired sample data is a simple random sample and that the differences have a distribution that is approximately normal. Construct a 95% confidence interval estimate of the mean of the population of differences between hospital admissions. Use the confidence interval to test the claim that when the 13th day of a month falls on Friday, the number of hospital admissions from motor vehicle crashes are not affected. So we already have our table. I need my differences. It's the same concept as a hypothesis test. It's just I'm making them rows now instead of columns. It falls the same way. So for my first difference is -3, then -4, -1, -2, and -3 again. All I did was subtract the numbers. Now that I have my differences, I can move on and start constructing a confidence interval. When constructing the confidence interval, we need to have a formula. The formula for this confidence interval is d bar minus t sub alpha over 2 times s sub d over square root of n, which is less than mu sub d less than d bar plus t sub alpha over 2 times s sub d over square root of n. The only thing that changed from the left side to the right side is that minus sign went to a plus sign. Now we need to find out what these values are. D bar is the mean of all the differences. It's from that D row actually. I know I wrote column, but it's actually a row from left to right. So D bar would be -2.6. S sub d is also from the D row. It would be equal to 1.140175. N would be my sample size, which is 5. And while I'm at it, let's go ahead and do degrees of freedom. Degrees of freedom is equal to n minus 1, which is equal to 5 minus 1 for us, so that's 4. Now that we have these values, we can go back and find that t sub alpha over 2, our remaining value. So that'd be t sub 0.05 over 2, which is t sub 0.025. We can look that value up in the t table with 4 degrees of freedom, and we will get 2.776. Now that we have all these values, we can start plugging these numbers into the formula. So we will get -2.6 minus 2.776 times, and I'm going to put this in parentheses so you know it's times the whole thing, 1.140175 over square root of 5, close the parentheses. And that's less than mu sub d, which is less than the exact same thing but with a plus sign instead. So we can put this in the calculator. If we put the one with the minus sign in the calculator, we will get -4.02 less than mu sub d, which is less than, if you put the plus sign in the calculator, you'll get -1.18. Now what's special about this is if you look at this confidence interval, it does not contain 0. Since this does not contain 0, we're saying there is some kind of difference. They are not the same. If you have any questions about this, please contact me through course messaging or post in the discussion board on Blackboard.